I'm making a full-size two-person flying boat wing and ground effect boaty McPlaney thingy, and I've made a lot of progress and I want to show you because it's getting exciting now. The electrics and engine gauge pod are installed, and this is where I've mounted it. It just transferred from the Polaris Fib, so it was pretty quick and easy to install. We have engine temperature, engine RPM, dual exhaust gas temperature and the hour meter. I don't think any more gauges are going to be necessary for the time being. This is where I've mounted the throttle, and the aluminium tube can double up as a grab handle. I might add another throttle somewhere for redundancy, as there's already two cables. This is where I've installed the battery. I just need to make a clamp so it can't come out. The battery isolator and electrical box is mounted. The fuel tank mounts are made but not welded in yet. It will be held down with straps. I'll probably mount it slightly forward of the CG just to help with the nose weight. Of course the weight will reduce as the fuel is being used, but there will always be a minimum amount of fuel in the tank providing ballast. The engine radiator is installed. This is a classic mini radiator which I bought, and I moved the outlets to suit the hoses. This is the nice thing about aluminium radiators, you can easily modify them to suit. I'm not far off being able to start the engine, which will be nice. I'm looking forward to testing the tail control surfaces with some air blowing over them. It would actually be possible to drive around with the boat on the trailer. I suppose if you went fast enough, it would take off from the trailer. The tail control horns stroke mechanism is pretty much done. I resorted to CAD to check the rudder cables are moving in the same distances, which wasn't as straightforward as I thought. What I did was draw lots of lines spaced 10mm apart on the lever retract and lever pull sides to see if they were moving the same distances throughout the throw. I've sized the levers so that the hinge is in the middle of the diagonal. On my first attempt, I had the hinge in the middle of the straight distance, which was completely wrong. So that explains why, when the rudder is straight, the connecting levers are at an angle. I didn't understand this previously, but now it makes sense. However, although I think the dimensions are all correct, that doesn't mean that it's the perfect system. It seems you can either have the cables going from tight to slack, or slack to tight during rudder deflection, and actually, if you deflect the rudder more than 25 degrees, that scenario reverses. Up to 25 degrees rudder deflection, we're not talking about a lot, only a couple of millimeters of change in cable tension, which I've already checked in real life, and you can't detect any change in control stiffness or noticeable cable tension. I'm happy enough with this to continue, but I will be putting on brackets to keep the cables from coming off the pulleys. I need to make sure these brackets cannot come loose and jam the cable. A safety feature turned into the cause of a failure, which can happen quite easily with design decisions. The pulleys I've made pressed-in oil-light bushes, which run on a stainless steel tube. The tube is clamped with a through bolt, and I'm very pleased with all of these. All-light bronze is surprisingly expensive, but should be low maintenance. The elevator cables connect to these blocks, which also have the stainless steel tube pressed into them. There will be additional cables connecting to the elevator, which provide strength. I've designed all the control surfaces to accommodate twin cables, but that decision might be a bit over the top. We will see what the control stick forces are like during testing. I've ordered Sikonite wing covering and the adhesive to cover the tail. The adhesive is a water-based Stewart system which looks very nice to use. There's a great set of YouTube videos on how to apply the fabric. Really looking forward to this stage. The wing spars attached with a sliding fit and are held in with stainless pins. I thought of securing the wings with these nuts, but even though the name suggests they are suitable, I decided against that. I haven't exactly figured out how I'm going to cover the wings, but it will be a single skin wing. There won't be any specific aerofoil shape, just whatever shape the air inflates the skin to. Just like the hover wing or mud skipper machines. Also, no ailerons are planned, just 2-axis control, but they could be added at a later stage if needed. If I don't think ailerons are needed, then flaps could be added instead. The current empty weight without wings is 200 kilograms. For comparison, the empty weight of the Polaris Fib was 220 kilograms without its wing. The flex wing of the Polaris Fib weighs 50 kilograms, so if I can make wings within this weight, the overall weight is looking acceptable. Wing struts will be needed. Also, I need to make reinforcing internal tubes to strengthen the wing spars. I'll then need to do a wing strength test by loading the boat with sandbags. No doubt there will be some unwanted flexing to address, but hopefully it will be solvable without adding too much weight. I haven't done any more microlight lessons, only managed 2. I did book about 10 lessons in a row, all of which were cancelled because of the weather, but that was during the winter when the weather wasn't favourable. I'll perhaps try again because I think it would be of benefit, even though the microlight was a 3-axis control and mine will be a 2-axis control. It's funny, there are stages during this build and the helicopter build where you can't remember what the reason was you started building. It just seems like a never-ending task and you ask yourself, why am I doing this? But you must persist during these times and just keep going. There comes a time when there is light at the end of the tunnel and you start to get excited about the project again. You remember why it is that you want this and the enthusiasm comes flooding back. That's the stage I'm at, and that's why I'm excited to make this video. I think it would be a good idea to test the tail on the water without the wing fabric in place. Any problems will hopefully be highlighted. Although speed along the water will max out about 30 miles an hour, and flight cruise speed will be higher than that. Perhaps 40 to 50 miles an hour is what I'm expecting, and to test the tail at that speed I would need to trailer the boat along the road while playing with the tail control surfaces. We'll think about that. To end the video, here are some highlights of the Royal International Air Tattoo. I've never been before and it's a great show. Enjoy.